Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi.
Apa khabar semua? Sihat?
Alhamdulillah.
Okay, sebelum start, macam biasa. Anything from last time, last class? Any problem? Any question? Okay, alright, good. So today what I will do, we continue with the partial derivative. I think I covered just a little bit last time. So let's continue from there. If you recall, when we left last class, we were doing the graph. Okay, the graph. As you know, when you have two independent variables, there will be a graph of 3 dimensions. So it's like an object. So let's continue from there. I will show you again the diagram. Okay, so this is the diagram that you have in the book. It's in chapter number 14, the first diagram. So you'll see here, it's like the x and y are the independent variables. Z is the dependent variable. So that's how the graph look like. And every line is in perpendicular to each other. So 90 degrees. The y and z is separated by 90-degree line. So here you will see 90 degrees. And everywhere will be 90 degrees. So total is 360. Okay? So that would be the graph. Now, how do you locate a point? So secondly, you want to identify a point. Now, since you have the function z as a function of x and y, the point would be indicated by x, y, z. So that is the ordered pair. Now it's not ordered pair, it's ordered triple. It's not pair anymore, no, it's a triple. So the point is defined or described by x, y, z. So how do you locate the point? So that's how we want to do. Locate a point. That means how do you locate? For example, a point 2, 4, 10. No, example. Now, firstly, when you want to locate a point, you consider only the x and y. That is 2 and 4. Because the x and y are the independent variables. So you look at the point, okay, the point in terms of x and y. Okay, that one we know already from last topic. So example here, if I have 2, 4, so we make a scale, scale for the x and y and everything. So let's suppose this is 5, here is 10, and then here you got 5, and you got 10, and here 5, 10. And let us also indicate the negative. So here negative 5 for the x, and then here is negative 5 for the y. Here is negative 5 for the z. Okay, so those are the negative values. That means the other side of the origin. So firstly, you get the xy. Now xy would be the point on the xy plane. Okay, so just worry about x and y. So x and y would be x and y, x, y. So suppose this is x, that's y. So xy would be there. So that's xy. So xy. Example 2 and 4. So what we have? We have, I use another color here. 2 and 4, the x is 2 somewhere here. Y is 4 somewhere there. So the point would be roughly here. So that is xy. Now, from the xy, you will go to the corresponding z. So here, 2, 4, you go to corresponding z, which is 10. That means you go along the z-axis. So 2, 4, or xy, suppose it's here, then the corresponding value of z would be somewhere there. That means you go upward. So that is z. All right. So therefore, that is our point. X, Y, Z. Okay. So that's how we do it. So go to that example. 2, 4, you already determined is here. The Z is 10. So 10 will be somewhere there. So we go up. That will be here. So that is the point. 2, 4, 10. Okay. Any question? All right. Okay, if you draw the graph, okay, if you don't draw, then tak boleh buat apa lah. If you draw the graph, I would like you to find, okay, just locate one point. Example, I give you another point. So locate, okay, locate 10, 10, 10, negative 5. Okay, locate that. I already get the scale, in 5. So if you draw the diagram, you follow the scale. All right, now locate that point. So just follow the method that we just described. Firstly, you get the xy, and then go to the corresponding z. Okay, now, for those who do it, where is the point? Anybody get it? Anybody? Okay, where is that point? Tak ada orang dapat ke? Where is it? Okay, somebody. Huh? Okay. Anybody get the point? Let me just tell me where is the point.
Sir,
Is it? Yeah.
maybe for the x equals to 10, maybe some inline x, the 10.
No, maybe you just maybe you just tell me where is the point?
Oh,
Yeah, betul lah tu x10 and then y. Just tell me the point. Is it up there or down back or to the left, the right? Where is it?
Down to the right, sir.
Down again. You have 10, x is equal to 10, y is equal to 10, will be somewhere here. And then z is equal to -5, will be down there. Okay, -5 is here. But you know, the 5 is of course there, but you don't draw it as a straight line. You since that is the flat, because you know, 10 and 10 will be here. Okay. Now 10 and 10 is the 10 and 10 will be on the xy plane. So actually it is above -5. So -5 is here. So -5 is here. You go down, -5 will be there. So somewhere here. All right. So that will be the point 10, 10, -5. All right. Okay. So that's how you locate a point. Now we go to the graph, and you know the graph of a certain function. So as I said earlier, what you get is an object. Okay, it's three-dimensional object. It's just like if you go watch a movie, you know, movie in 3D. So that's how it look like. And in fact, you know, 3D is Earth. You know, on Earth, on Earth, or Earth, on Earth. On Earth means everything on Earth. Living creatures or non-living creatures like houses, you know, cars, or all in 3 dimensions, including people, animals, all 3 dimensions, right? So that's the object that look like in the graph for a function with 2 independent variables. For an example, for a proper function, you can see figure 14.2. So look at figure 14.2. You will see, you know, for that function, what is the function? The function is z equal to 4 minus x squared minus y squared. Okay, how does the graph look? How does the graph look like? If you look at the graph 14.2, how do you describe that object? Object itu macam benda tu, macam apa? That object is like what? Like a dome. Is that right? Like a dome. It's not a cone, you know, it's not a cone. It's not a sphere. It's somewhere in between. So it's like a dome. So it's an object, all right, described by that function. So something like a dome. Okay, so that is an example. All right. So let's say we start from this example. You want to find, okay, so next is you want to find z given a certain value of x, y. So how do you get the value of the function? In other words, given a certain point or a certain value of x and y, we can find the value of the function or z. Example, let's say x, y equal to 2 and 1. Then how do you get the value of the function? So simply what? Simply do the substitution. Okay, so you substitute x and y into the function, then you get the value of z. You know, there is no new method. The method is already something that we learned. So you substitute, what I get will be z equal to 4 minus 2 squared plus or minus 1 squared. So you get whatever the value is. So that's how we do or we find the value of the function given certain values of x and y. Okay, so you can do this kind of example, this kind of work in 14.1. Later on, I give you some questions. Okay. Now the application, don't worry about that. We come back afterwards. What I want to do next is I want to do the derivative. So the derivative is what you call for this kind of function the partial derivative. Why partial derivative? Because there are two independent variables or maybe more. When you differentiate, we differentiate only with respect to one independent variable at a time. So that's why you call it partial. It's not a total derivative, okay? It's a partial because there are two or more independent variables. And at one time, we differentiate only with respect to one independent variable. Okay, so that's why you call it partial. So this is what we want to do now. All right, so notation, okay, notation. Or before I say notation, I give you the idea. Okay, idea, here you got z equal to f of x, y. I already mentioned to you, why we call it partial, because you differentiate with respect to only one independent variable. So based on that idea, that idea, we make it more formal. So here, if you differentiate, okay, I differentiate z, the independent variable, with respect to x, because we differentiate only with respect to one independent variable. With respect to x, what do we do to y? We keep y constant. So we treat y as a constant. Y is a variable, but when you do the derivative of z with respect to x, you keep y constant. Okay, so that's the partial derivative of z with respect to x. Now, you have two independent variables. I can also differentiate, but I can also differentiate z with respect to what? Z with respect to, okay, with respect to, now I can use short form, with respect to, we can say WRT, with respect to y. Okay, so what do we do to the other independent variable? We keep x constant. Okay, so when you take the derivative of a function with respect to one independent variable, all other independent variables we keep constant. All right, so that's the idea. All other independent variables we keep constant, regardless of how many independent variables are there. All right, so here we only consider two independent variables. You take the derivative of z with respect to x, y constant. You take the derivative of z with respect to y, x will be constant. Okay, now notation, I just tried it on the same level. Okay, so notation will be what? dz dx. So here, the derivative, the d is delta, the slanting d. It's not, normally we write what? dy dx, okay? The normal d, but here you have the delta d, the slanting d. So dz dx, or we can write as zx, or we can write fx. So fx here, this is subscript, subscript. I mean, you write small at the bottom, not like f a function of x, So that is the notation. So of course you can, I think that this is the most common notation that we use. And then for the derivative with respect to y, we call it dz dy, or we can use zf or fy. Okay, so these are the common notation that we normally indicate the partial derivative with respect to the particular variable. Okay, you understand? Anybody has a question? So make sure we do understand the basic idea. right? When you differentiate the dependent variable, we differentiate with respect to one independent variable. You keep all other independent variables constant. So if I differentiate z with respect to x, y will be constant. If I differentiate z with respect to y, x is constant. Okay? All right. So that is what you call partial derivative. Okay, so that's where the word come partial here. Okay, partial derivative. So let's look at a few examples. Now, when you look at example, how to do the derivative, the rules that we learned earlier, the product rule, quotient rule, constant rule, whatever rule that we learned earlier will be applicable. So there will be no new rules of derivative. The derivative, the rules are the same. Okay, so there is no new rule. So number one, the rules already we know. All right, whatever the rules that we learned earlier is applicable. Now, number two, there are two types of functions. One, the x and y, the independent variables, are additive. Okay, they are the additives. And then the other type of function, the x and y, some of them are multiplicative. Multiplicative. Example, I have z equal to x squared plus y to the power of -4 minus 25. So here you see x and y are additive. Now multiplicative, you have something like this. I have 2x to the power of -4.5 multiplied by y to the power of 10 minus x to the power of -7 plus 2y to the power of 1/2. Okay, so here you have what? I have multiplicative. The x and y are multiplied to each other. The first example, or even here, they can be combination of the two. Here you have additive. Example here, additive. This is multiplicative. So there are two types of function, and we should get the idea, okay, and on how to do the derivative. Okay, all right. So number three, when you do the derivative with respect to one independent variable, the other independent variables will keep constant. So that is the basic rule. All right. So you have to know, okay, one variable is the constant. No, variable constant, one variable is the variable. That is a variable that you differentiate with respect to. All right. And the other variable, okay, the other variable are constant. So that is what we want to do. How do you do that? All right. So when you treat the other variable as constant, you apply the constant rule. Okay, the constant rule. Now, what is the constant rule? If I have, for example, okay, we go back to the rule that we learned earlier. If I have y equal to 5, then what is the derivative of y?
0.
0. It's a constant. Okay. And now, if I have y equal to 5x to the power of 3, okay, you have a constant which is multiplied to the x, the variable. What is the derivative?
15x squared.
15x squared. The 5 will follow the derivative. Okay, don't worry about the 5. The 5 will follow the derivative. You got that 5, and then you got 3x squared. Now, this rule you should remember. Okay, apply it to the one that we're doing now. So given that, okay, we look at some examples. So here, example number 1, we go back to the book, they give you the example in the book, the one that gives, the cone, the cone, the dome. So we start with that one. You got z equal to 4 minus x squared minus y squared. So very simple example. The x and y are additive. Additive means can be subtractive lah. So number one, you differentiate the function z with respect to f. Sometimes I like to use f. So I put both. Okay, I put z equal to f y. So we write both. First, you want to do take derivative with respect to x at zx or fx. So here you treat y constant. So that y here is constant. Now, when it's a constant, you think of it as a number. Think of it as what? Say 10 or whatever, 20, 5, all right? Think of it as a number. So if you differentiate a constant, what do you get?
0.
0 lah. So that would be 0, okay? The variable is only x, okay? So what is the derivative? Now 4 is of course a constant. The variable is only x squared. So you got negative 2x. The y squared is a constant. It's not constant. You treat it as a constant. Okay? You think it is constant. Only when what? Only when you take derivative with respect to x. Okay? All right. Now, secondly, I take derivative with respect to y. So you got fy or zy. So now, what is the variable which is a constant?
The x square.
The x lah. Okay, so that is now a constant. So you think of it what? Think of it as a number lah. 4 ke, 2 ke, whatever you want to think of, that's a constant. So derivative of a constant, what is it?
0.
0. Okay, that's a constant. So what is the derivative of the function with respect to y? Y squared is the only variable. So it's negative 2y. All right. Okay. Okay. Let's consider another example. So you go to 14.1. Okay, there are a few more examples that we can do. So let's say we do another example. So example number 2. This one very easy. Z equal to 4x minus 3y. Okay, that's question number 2 in the book lah. Okay, so now I want to find the derivative of the function z with respect to x. Okay, what is it equal to?
4.
4. Okay, that's a constant. Okay, that's a constant. So 4. And then zy, what is it? So when you do zy,
Negative 3.
benda ni constant. Okay, so negative 3. All right. Okay, good. Now I want you to do question number 3. Okay, now I want you to do question number 3. Now question number 3 is not as simple. You need to apply, or what you need to do. You need to apply what? Because there is only one term at the bottom, so you may apply the product rule. You bring the y upstairs, so you do it like this. 4 minus 3. 4 minus 3. Z equal to 4x minus 3. Kita buat nombor 4. Nombor 4 tu lagi sedap. Number 3 ni simple. Okay, you do question number 4. So number 4, you bring the x, the square of x up there. So z equal to x plus y squared multiplied by x to the power of half. Okay, so I want you to try this one. Okay, I want you to do the product rule. Of course, you can multiply out directly. Yeah, I think you can multiply out easier. But you use the product rule. Okay, use the product rule. Or you can multiply out. I give you another question, for the product rule. So for the product rule, okay, I give you another question. Suppose you got x -2 plus y multiplied by x to the power of 3/2 minus y to the power of 4. Okay, I put here and then here I put 2. Okay, but your first one dulu. All right, do the first one. So the first one, dia buat macam ni je. You multiply out, senang cerita. Okay, so you'll see here, you got x to the power of 3/2. Okay, plus y squared x to the power of half. Oh, ni tak boleh buat dulu. In order for you to do this, we need to do the term, the second part, the multiplicative. Okay, hold on. Kita come back later. Okay, come back afterwards. This one, we need to come back. Okay, so I come back to that afterwards. Now I will use the other type of function. So here you have the x and y multiplied to each other. Okay, so that is the second part. Okay, so example, I have z equal to x squared plus 10 x to the power of 4 y to the power of 6 minus y to the power of -3/2 plus 24. Okay, now here I have a multiplicative terms. All right, so before we do that example, I'll give you a simpler example for multiplicative. Let's say you got x equal to 4. Kita simple. We start with the simplest example. X to the power of 5, y to the power of half. Okay, so here you see they are multiplied to each other rather than added or subtracted. Okay, now I want you to try this. Okay, find zx, find zy. Okay, find the derivative. Now I give you 1 minute. Okay, Siti Nur Farah. Siti Nur Farah, are you here? Okay, what is zx? The derivative of the function with respect to x. What do you get? Tell me. Whatever you get, you tell me. Doesn't matter, Don't worry whether it is wrong or whether it is right. Huh?
5x.
Zx 5x. Itu je. Siti. Belum, dah habis ke belum tu? 5x lah. Okay, Nur Saidah. Where is your picture? You know, you should put your picture here. Nur Saidah. Okay, what is the derivative? Letak picture. Ni Nur Liana pun tak ada picture, Nur Saidah pun tak ada picture lagi. Okay, what is the derivative?
5x power of 4,
Okay, 5x over 4.
y half power of 1 over 2.
Okay, y to the power of 1 over 2.
Yes.
Okay, y to the power of 1 over 2. Now, is that right? Or is that wrong? Anybody who get a different derivative than this one? Cepatlah. Anybody who get different? Semua dapat sama, eh? So this is correct or this is not right?
5x power of 4.
Okay, so another derivative will be just 5x to the power of 4. So most of us, okay, will either get the first one or get the second one. Now, is there anybody else who get the second one? Okay, all right. Siapa tadi yang kata the second one tu? Siapa nama?
Me, Nabila.
Oh, Nabila. Okay, Nabila. Okay, Nabila. Okay, I want to talk to you. Of course, everybody else also lah. Okay. Now, why your answer is 5x to the power of 4?
Because the y is constant.
Okay, because y is a constant. Okay. Now, when y is a constant, that y is multiplied to the x. Okay. So if multiplied to the x, I think what you were thinking was, when y is a constant, the derivative will be what? Will be 0, kan? Okay. Now, if it is 0, okay, if it is 0, you multiply by the x, 5x over 4, dapat apa?
0.
Dapat 0. Okay. So now, you think of the other constant, 5 ni. 5 is a constant, right? So y is also a constant. Okay, y is also constant, but that y is multiplied to the x. That's like 5. Okay, so 5, the rule is the constant will follow the derivative. So 5 is what? 5 is there. Oh no, 5 is there. 5 is just a constant. So 5 tak ada apa. Okay, nothing to do with the 5. Okay, because 5 is the one multiplied. So I give you another intuition. So katakan y equal to 5x squared. The constant, okay, the constant will follow the derivative. So y prime equal to 5 multiplied by 2x. So here, y to the power of half is a constant. So the constant will just follow the derivative. Okay, so it is not gone. It will be there. So the y and half will just follow the derivative. So the derivative will be what? The derivative will be 5x to the power 4 multiplied by y to the power of half. Okay, y to the power of half will not be gone. It will be there because y to the power of half is a constant. So we keep it like that. Okay, Nabila, do you understand? Do you understand what I'm trying to say?
Yes, thank you, sir.
So macam ni.
Yes.
Okay, in order to think of that y as a constant, we, when we start to learn about this, we do the y as a constant. So what you can do, you write z is equal to, because y is a constant, you want to find zx, okay? So y is a constant, you put y as a coefficient of x to the power of 5. So here, this one is the constant, okay? So the rule constant, if it is multiplied with a variable, will just follow the derivative. So therefore, zx will be equal to what? Will be equal to y to the power of half, okay, which is the constant, multiplied by what? Multiplied by 5x to the power of 4. So which is exactly what you have here. All right. So this is just to get ourselves familiar with the concept. Okay, so that's a constant. Okay. All right. Now you find zy. Okay, so you find zy. The x to the power of 5 is a constant. Okay. Okay. Now we go ahead find the derivative of the function with respect to y. Okay, dapat lah. Everybody got it? Okay, so now let's see. Let's see what we have. Okay, anybody wants to share the answer? Okay, is that what did you get? Z, Y? Is that, are you here? Hello? Tidur ke apa? Okay, Hairul Asri. Is that ni bisu ke apa? Okay, it's Hairul Asri. Z, Y, what is it? Whatever you get.
X5.
X5.
2y 1 over 2.
2y 1 over 2. Okay, your idea is correct. Okay, because when you take derivative with respect to y, the x over 5 is a constant. Okay, so constant will just follow the derivative. I just differentiate y to the y to the power of half. But the derivative of the y is not correct. So you got y to the power of 1 over 2. So how do you differentiate that? If I differentiate that, what do you get? You don't get 2. You don't get 2y to the power of half. What do I get? What's the
1 over 2y.
1 over 2.
1 over.
So it should be x power 5, 1 over 2, y. You reduce
To
the power
the
by
power of negative 1 over 2.
negative 1 over 2. So please, you have to do more practice to make sure practice more so that we can do the derivative. Okay, you know the rule. You know the rule that is a constant. But unfortunately, the derivative is not correct. So review balik. So that's the application of the rule. Okay, you differentiate with respect to x, y constant, differentiate with respect to y, x constant. So treat that variable which is a constant, imagine it as a number. So that means it follow the derivative. Okay, all right, I'll give you another example so that we will be familiar, and then we can try to do a more question like in 40.1, you know, you can apply the product rule, things like that. Okay, I'll give you another example. Z equal to 10 x to the power of what we apply? To the power of negative 2.5, and then y to the power of 7. Okay. So by now, we should be able to get the idea. All right. So I want you to find Zx and then find Zy. Okay, do it now. The 10 is a constant. All right, 10 is a constant. So that is a pure constant. So it's clear. Okay. The one that is not so clear is the variable that you treat as a constant. So we already done one example. So apply to this example. Okay, do it now. I give you 1 minute.
Sir,
Yes. Apa dia? Yeah, what is it?
sir. Afiq Danish terkeluar daripada Zoom sebab rumah dia tak ada current.
Siapa dia? Rumah siapa?
Afiq Danish.
Oh, okey. Rumah dia tak ada current. Okey lah. Patutlah saya
Dia
panggil.
terkeluar.
Tak ada. Apa saya pun tak ada current pula. Blackout ke? Rumah dia kat mana?
Ya, sir. Dekat
Kat mana rumah tu?
Sabah.
Sabah? Oh,
Sabah.
Sabah biasalah. Bukan Sabah je, kat mana-mana pun biasa juga. And sometimes the blackout can be long, you know. Okay, so tak apalah. You tell him to get recording. I hope I can upload the recording earlier. Okay, so I hope I can do that recording by tomorrow ke by Friday. Alright. Okay. Afiq ni orang Sabah. Alright. Okay. So tapi sekarang ni the COVID-19 dah meningkat. The COVID-19 is increasing the rate. For Kelantan, Kelantan is going to be top 5 now. And then Sarawak. Sarawak used to be a very safe state, but now Sarawak, let's go. So if you are from Sarawak, if you're in Sarawak, take care. Selangor, Selangor is of course always the state that with the most, but I think because Selangor has the most people. But Kelantan, Kelantan is increasing in number. So if you are Kelantan, take care. Dah Tarawih pun dah tutup lah in Kelantan. I heard yesterday the Tarawih in Surau, the local mosque is closed. You only have Tarawih in the state mosque. So susah lah nak pergi state mosque lagi Kota Baru. And other district mosque. Okay, come back to here. Alright, what is the derivative of Z with respect to X? Lepas ini tak kira lah, siapa pun boleh cakap ni. Saya tak payah panggil nama.
Y power of 7.
Y to the power of 7. Okay, y to the power of 7, that's a constant. Okay, so it's good that you put at the beginning. All right, after tu?
25x power of negative 3.5.
Sebelum 25 tu, 10 tu buat apa?
10.
So 10, okay, 10 will be there. So 10 will be there. 10, y7. So that is the constant. Two constants. One is 10, the other is y to the power of 7. The only variable is the x to the power of negative 2 over 5. So you multiply by negative 2.5, and then the x reduce the power by 1, so that becomes what? Negative 3.5. Okay, good. Of course, after that you multiply lah. Like what she did, she multiplied directly 10 with negative 2.5. But for now, okay, don't multiply yet. You multiply on the second step because we want to see, okay? You want to see the constant. Okay, all right. And then of course you can simplify. Okay, good. Now ZY tu, ZY apa?
10 x to the power of 2.
So you got 10, okay, x to the power of negative 2.5. Okay, these are the constant, okay?
Yes.
And then you multiply by 7, y to the power of
Power of 6.
to the power of 6, negative 6.
6.
Power of 6. All right. So you can multiply the constants, 10 and 7. Okay, now, the reason we do this, so that we understand the concept. Now, once you understand the concept, you don't have to rearrange. Okay, once you know how to do the partial derivative, you know that the other variable is a constant, you don't have to rearrange. Okay, so you can do directly. So this one is only when you want to get the idea. But after you are good, all right, so you don't have to do that. You just do directly like from the question. So for example, that x is equal to what? Is equal to 10, negative 2.5, okay, x, negative 3.5 multiplied by y to the power of 7. Because you know that is the constant will just follow the derivative. So you don't have to rearrange. Okay, why we rearrange? Nothing wrong with it. Because you want to make sure, okay, that that variable is treated as constant. So you put it just like coefficient. Okay, okay. But once we understand the concept, then we can, we may do it directly. Okay, all right. So let's look at another example, which is application of a few other rules. All right. So let's look at the question number 5 in the book. Okay, question number 5. 14.1. Question number 5. Number 4, number 5 lah. Okay, number 5. So here we apply, I think before we do that, I give you a product rule dulu. Okay, this one kita nak guna quotient rule. So I give you a product rule first. So another example we give is product rule. So let's say z equal to 5x plus y cubed to the power of 5 multiplied by 3x to the power of 3 over 2 minus y to the power of negative apa? Negative 4. Everything squared. So here, okay, in order for us to find the zx or zy, we have to apply the product rule. It's not that straightforward. When you apply the product rule, again, the concept, you take derivative with respect to x, y is a constant. You take derivative with respect to y, x constant. Okay, all right, I want you to try this. So you let u be the first term, and then v be the second term. Take u prime, v prime, okay? But remember, when you do the v prime, u prime, is it you are doing zx or you are doing zy? Okay, so we start with the one zx. Okay, I give you 3 minutes. This one. Okay. So recall the rule, okay? The product rule, you know, apa dia product rule? Product rule, y equal to u prime v plus v prime u. So y prime. So sama juga. Zx equal to what? You let this be equal to u. You let that be the v. So zx is u prime v plus v prime u. Now, let v and u prime is what? Is derivative with respect to x. Okay, derivative with respect to x. That means you keep y constant. Okay, all right. So we let u be equal to the first term, 5x to the power plus y cubed. Okay, to the power of 5. So now, okay, the variable is x. Y is a constant. Okay, so how do you do the derivative? So the u prime will be what?
Five. Five.
You have 5, and then everything in the
5x.
bracket. Okay, everything in the bracket,
Power of 4.
the power of 4, and then you have to multiply by u prime.
5x.
Maknanya kita, you know, this thing here is so multiplied by 5. Okay, because the variable is 5x. So actually, you know, this u is equal to this thing. But when you do the derivative, okay, you have to remember, you have to know the way, right? You have to know the way. You know, you have to differentiate the terms in the bracket as well. But the terms in the bracket, y cube is a constant. Okay, so we multiply by 5, derivative of the 5x. Right. So look at the second term, v. I have 3x to the power of 3 over 2 minus y to the power of negative 4, okay, squared. So when you take v prime, we take derivative with respect to x. Okay, y is a constant. So what is it? So you got 2 multiplied by everything in the bracket. Okay, reduce the power by 1, and then you have to differentiate the terms in the bracket, which is the x only. So that will be equal to what? Because y is a constant. So that will be equal to 3 multiplied by 3 over 2 x 3 over 2 minus 1, that will be to the power of half. So you got 9 over 2. Here is 9. Here is 2. So that one cancel out. So you got 9. So this is v prime. That's u prime. Put back into the formula. You will get zx. Okay. Okay. So this, you know, for this one is an extension of what we learned earlier. Okay. All right. Okay, I want you to get that. Okay, got it? Okay, so you finish it up at home. Okay, finish up later because I need to look at ZY. Okay, ZY, same thing. When to do ZY, you still use the U prime plus V prime U. But here, the derivative all right, is what? In respect to y, not with respect to x. Okay, the prime here is derivative with respect to y. So you let u again be equal to the first part, 5x plus y cubed to the power of 5. Okay, now what is u prime? Here, derivative with respect to y. Okay, so remember it's respect to y. So again, the rule is, since y is inside the bracket, the rule is take the power, reduce the power by 1, and then you take derivative of the terms in the bracket. So what is the derivative of the terms in the bracket with respect to y? Okay, apa dia? Cepat.
square.
3y squared. Okay, so that's 3y squared. So now v prime, you take derivative of the second part. I'm sorry, v dulu, v dulu lah. I know. We take derivative of the term with respect to y. All right, so that will be equal to 3x to the power of 3 over 2 minus y to the power of -4, everything squared. So v prime is derivative with respect to y. All right, so again, the rule applies. So you bring down the power multiplied by the terms in the bracket, reduce the power by 1. Okay, so that's 1. And then take derivative of the terms in the bracket with respect to y. So what do I get? Not 1 over 4, I'm sorry, it's to the power of 4, -4. Okay, so what is the derivative of the terms in the bracket with respect to y? What is it?
4y to the power of 3.
4y to the power of, you bring down the -4, multiply by -1, so that becomes +4. Y reduce the power by 1, akan jadi 3. It's -4,
85.
-5. Okay, so that's v prime. And then apply, put back into the formula. Okay, so everything or the rule are the same, except that you must be careful. Are you differentiating with respect to y, or are we differentiating with respect to x? When you differentiate with respect to y, x is a constant. Okay, differentiate with respect to x, y constant. So you can also look at the quotient rule. Okay, quotient rule, which is some of the questions that is given in 14.4. So I will, I think I have shown enough example. So for 14.4, all right, you should do the question. I give you more questions from 1 up to 12. Okay, so 1 to 12, I would like you to find zx, zy, or you can use fx, or we can use fy. So you see here the question, there are just regular question, just apply the power rule. Some will apply the product rule, and a few we apply the quotient rule. So we do the product rule, and the quotient rule you do, okay? Especially question number 5, 11, 12. You can do the quotient rule. So take the derivative, and then do it. Do it slowly first. Okay, do it slowly. Don't have to run. Okay, all right. And a few more application of the quotient rule that you can try. Do number 15 and number 16. Okay, number 16, they have tak payahlah, because number 15, 16 is not a function. It's it's the derivative already. So 15, 16 tak payah buat. Okay, 1 to 12. Okay, Any question? Anything? Okay. But normally, okay, for our application, we don't normally look at the quotient rule. You know, most of the time we only deal, you know, product rule. Or more common is just simply the power rule, yeah. Okay, power rule, and sometimes you have the product rule. It's quite rare that you use the quotient rule. Okay, quotient rule ni jangan sikit lah. Okay, quotient rule jangan sikit. But you do quotient rule also for question 11 and 12. Alright. Okay. Any question? Alright. Good. Okay. Good. We already do enough question. Okay. Any other things? Yang ini bagus ni. Question yang tu. Oh, actually, the power rule, the product rule, and the quotient rule, they give you some examples, you know, in 14.2. So, 14.2, I'll give you also some questions. These are good questions that you can do the derivative. Also, 1 up to 12. All right, you will see there 14.2 product rule, quotient rule. Okay, so quotient rule, product rule, everything covered. That is in chapter 14.2. Okay, all right. So I think Bagoni, you practice a lot, okay? So that we will be clear on that. All right. Now next we want to do the second partial derivative. Or second partial. Second partial derivative is just like the second derivative. When you differentiate the first derivative, you get the second derivative. So here we have the first partial, differentiate the first partial, we get the second partial. So you got the function z equal to fxy. Number one, the first partial. Okay, the first partials are what? Zx equal to fx, zy equal to fy. Okay, these derivatives, okay, this derivative fx, fy are functions. So these are functions. Okay, now when they are functions, you can take derivative. So the second partial will be what? Will be the derivative of the first partial. Okay, so here you take the derivative of the derivative. So that would be what? That would be the second partial. So the second partial derivative is the derivative of zx. Okay. So number one, you consider zx equal to fx. Now, this is a function. Function. Now, if it is a function, then we can take derivative with respect to what? You can take derivative with respect to you differentiate. Okay, here we're talking about partial lah. Derivative, take derivative or differentiate. Then we use differentiate lah. It's the verb. Differentiate with respect to what? With respect to x. So it's a function. It's a function of x and y. Okay, so zx is a function of what? X and y. So I can differentiate with respect to x, and I can also differentiate with respect to y. Okay, so that derivative with respect to x, fx or zx, I can differentiate with respect to x, I can also differentiate with respect to y, because it is a function of x and y. Okay, so when you do that, it's just like the second derivative. So if I take derivative of zx with respect to x, then I got zxx or fxx. Okay, now if I take derivative of zx with respect to y, I got what? I got zx y or fxy. Okay, nah, sama je macam you know, macam kita buat in the first in the just the direct derivative. Okay, here it's just partial, and you have the second derivative. All right, the second derivative or the second partial, zx, you differentiate with respect to x, and I differentiate with respect to y. Okay, so similarly for the zy, or the derivative of the function with respect to y, fy, is also a function. All right, and then you take the derivative with respect to pergi main kat luar. You take derivative with respect to x, and then take derivative with respect to y. So zy equal to fy is a function of x and y. Okay, so I can take derivative or I can differentiate with respect to what? With respect to y. You know, zy, I can take with respect to y, but I can also differentiate with respect to x. Okay, so what I have is zyy or fyy. And then for the second one, differentiate with respect to x, I got zyx or fyx. Okay, so for the second partial, I have 4. 1, 2, 3, 4. Okay, first partial, there are only 2. Second partial, 4. Because everything is the function of x and y. All right, so you can take the derivative directly with respect to itself, and then you take the partial with respect to the other variable. Okay. All right. Any question? So that is the notation. Okay. fxx, fxy, fyy, fyx. Or you can look at it in terms of z. So it's just simply the derivative of the first partial. So let's look at the example again. We already did a few questions earlier, so we just do that question. Okay, go back to the question, the first one. I think not, that's not the first one. Okay, first question. Okay, okay, this question, 4 minus x squared minus y squared. I think we did the derivative, or we did the first partial. That means the partial derivative of the z with respect to x and y. I think we already did that. Ada kita buat tadi. Cek balik. Okay, so differentiate with respect to x and y. Oh, okay, ni ada. All right. You already did the derivative. Okay, the partial derivative. We call it first partial. So here, first partial. Or just the partial derivative lah. So now, as you can see here, fx or zx is a function of x and y. And fy is also a function of x and y. All right. So you can take the derivative, the partial derivative, or the derivative of the derivative, or the derivative of fx or zx. You take the derivative with respect to x. What do I get? I get zxx. Take the derivative with respect to y. I got zxy. Similarly for this one, I take the derivative with respect to y. I got zx. No, ZYY. Take derivative with respect to X, I got ZYX. Okay. So now, take the second partial. Okay, do it now. Take the derivative of the ZX or FX with respect to X. Okay. Now, what is the ZXX? So I go back to the latest page so that we can find the second partial. Okay. So what is ZXX or FXX? That is the derivative of ZX, which is negative 2x with respect to x. So what? Berapa dapat?
-2.
Negative 2 lah. Okay, negative 2 because negative 2x. So now I take derivative with respect to y, fxy. Okay, what do you get?
-2.
Negative 2 because fx is negative 2x. Okay, now we are taking derivative of that thing with respect to y, not with respect to x. With respect to x, betul lah negative 2. Okay, but now you're taking that term, derivative of that function, which is negative 2x with respect to y. So what? What do we get?
0.
0. Okay, because the x is a constant. It's just like a constant function. Okay. So for the second part, z, y, y. You take the derivative of zy with respect to y. What do we get?
-2.
Negative 2. Because you have negative 2y. Taking derivative with respect to y, we get negative 2. Now, you take derivative of that negative 2y with respect to x. So what do I get?
0.
0. Okay. All right. Now we look at the second example. So second example. Okay, I give you second example. Let me see. What function do we consider just now? Yang ni susah. Kita cari yang senang sikit. Yang ni. Okay. So here, this is our second example. We have kita tak buat yang atas ni tadi. The one that I give you originally, yang ni, kita belum buat ni. Because what I did here, that's another, you know, that was another function. I
Belum,
didn't
sir.
do, belum. So this one you do homework, finish up at home. So for this question, I want you to do the same thing. I want you to do the first partial and also do the second partial. Buat dulu. Okay. All right. So now we go to this example that we already did. We have ZX, which is this one. And then I have ZY, you know, it's on the other page. So again here, I would like you to do ZXX differentiate with respect to x, and then zxy differentiate with respect to y. Okay, now we have 2 more minutes. I would like you to do that. Okay, do the second partial. Okay, you got it? Kita guna, you do zxx, lepas tu buat zxy. Okay, so what is zxx? When you take derivative of zx with respect to x, or y constant, okay? So if you go back to that example, zx is what is 5x over 4 multiplied by y to the power half. So zxx is, the constant is the 5, okay? And then you differentiate x to the power 4 with respect to x. So what do I get? I get x, 4x cubed. And then the y to the power half is a constant. So just follow the derivative. And like I said earlier, you can bring the y near to 5, okay? But by now, we understand how to do it already. Just leave it like that. So that is equal to 20 x to the power of 3, y to the power of a half. Okay, so now zxy. Differentiate zx with respect to y. So what do I get? So here, the 5 is a constant. X to the power 4 is a constant. Okay, the only variable is what? Y to the power of half. So what do I get? Half y to the power of negative half. Betul? Did you get it? If you didn't get it or you got it wrong, check where you make the mistake. Okay? All right. So now we do the zy. Okay? What is zy equal to? Zy equal to, or fy equal to, let me go back to the function. I already, I forgot that thing. I missed it. So it's mana tadi? Zy is equal to this one. Betul tak? Zy is equal to, okay, that is function. Zy is equal to x power 5 half y to the power of negative half. So you can rewrite that as half, okay, x to the power 5, y to the power of negative half. Okay, so that is our zy. So take derivative of that thing with respect to y. So what do I get? So z, y, y. So the constant will be half x to the power of 5, okay? And then the variable is y to the power of negative half. So what do I get? I get negative half, okay? Y reduce the power by 1, that will be negative 3 over 2. Betul tak? So you can multiply lah, half and negative half, that become negative 1 over 4. Okay, all right. Now z, y, x, differentiate z, y with respect to x. Now the x is the variable. So you got half, all right, multiplied by 5. reduce the power by 1, so x power 4 multiplied by y to the power of -½ Okay, so that is z, y, x. If you got it wrong, you go home, check again. Where did you went wrong? Okay, so that is the second partial derivative. Okay, all right. Any question? Okay, for this example, this one, okay, this one, and that one, this one, that one. Okay, one rule is that the zxy will be equal to zyx. If you do the derivative, the second partial derivative, this thing here must be true. The derivative of zx with respect to y, derivative of y with respect to x, they are equal. For example, here 0 and 0, they are the same. Okay, so for the second example, it's not so straightforward. I want you to go back to the zxy, simplify a little bit, and then fyx, you simplify a little bit, then you will see that they are equal. Okay, all right. So I give you enough questions for the weekend. I hope everybody will become a master of the partial derivative, the second and the first, so that when we will meet again next week, we're going to do the maximum minimum. So by the time, you know, everything will be just handy. Yeah? Okay. All right. Any question? Anything? Okay. So happy Ramadan for you. Happy berbuka. Kejap lagi. Ambil lagi lah. Lagi berapa jam ni? About 6 hours, 7 hours. So have a nice day. Have a nice weekend. Have a nice tarawih. I see you again next week. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam warahmatullahi.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
All right, thank you. I'll see you.
Thank you, sir.